All right, so we're gonna start the class. First thing is announcement. Your test 2 is already been graded, and you should get it in your college email. So if you did not get your test 2, I did scan it. It should be in your college email. If you didn't get it, send me an email. The key is also posted in D2L. Your grade is also posted in D2L. So I want you guys to check the grade that you have with the key and the grade, the key, and everything. So if I make any mistakes on the grading, I do make mistakes. So you have to email me and let me know, and I will correct it and give you the correct points. So make sure you guys let me know if I do make any mistakes, and if you need help or you don't understand any questions during in the test, let's say test 2 number 8, you doesn't know how to do that, or you don't get it, please talk to me after class, or schedule an appointment with me, and I can go over some questions with you. Okay, so that's one about your test 2. Second is no homework due tonight. So you've got 3 homework due on the next Wednesday, 6-1, 6-2, 6-3. We are almost done with 6-1. We have a little bit left with 6-1, and then I can combine 6-2 and 6-3 together in one section. But you have two sections of homework. That's the second announcement. You got 3 homework due on next Wednesday. The last announcement is you don't have school on tomorrow, Friday, and Monday. Okay, so no school tomorrow, Thursday, Friday, and Monday. So we don't see you on I don't meet you on Tuesday. So the next time I'll see you is next Wednesday. So you almost got a whole week, 1 week like spring break. So anyone have any questions with me with anything else? Also, can you guys take out the trig circles or unit circles? I think you guys got this in when you take your second test, right? So please take this one out. You guys have it?
Yep.
Okay. Who does not have this? Because we're going to use this today. And your next test, test 3, I will give you this same unit circle like this. Today, I will teach you how to fill in this unit circle. And same thing happens in the test. It's going to be like this blank. So you have to begin to fill it in on your own. So it's very important. If you do not have it, I will put this in the chat. Does you guys have it? So if you don't have it, please print this out in the chat room. Because I just put this unit circle trig in there, so in the chat room. So if you don't, it's the same thing as this. So if you don't have it, please print it out. Okay. So we stop at what we call as a linear and angular speed. This is still in 6.1. So what is a linear and angular speed? A linear speed is like a car when you travel in a distance directions, in a straight linear direction. Is using the formula of this. You guys know this already. So the linear speed we have here is where we use the distance over equals, so the linear, this is what you guys learned in the basic algebra, is distance equals to rate times times. This is called a linear speed. Okay. So in this case, we change the variables, so we don't call it distance. We call it s. I think it's a name for it. And then r is the velocity and t is time. So if you look at the linear speed v, you just divide both sides by t. So you find out that the linear speed is s over t, where s in this case is kind of like the distance over by the time. And this is when you travel straight, okay, like linear. So what happens if you have any particle, means an object, that move in a circular form, okay? So if you have anything that move in a circular form, you can kind of like, imagine this is a string, okay? You got a string, and the string can be laid down like that. Okay, you keep on, you got a string or a rope. Keep on doing like this, okay? So this is what we call as not linear because it goes circles. But if you unveil these strings, this string is actually going, is a forward. Okay. So so imagine this is your CD or your DVD. Okay. So when you put, how do your machine, your CD player or your DVD player read this? Is they will go to tracks, right? Track 1, track 2, track 3. So when they read this track, they read it in a linear speed. Okay, because you keep on spinning, this track will move in and out the circle. Okay, the track will move in and out this circle to and to read it is a linear one. Okay, and it's based on S. S in this case is the arc length, and it also based on the time. So how the time. So this is the linear speed. Okay, so when you have your reading of DVDs. Then we also have an angular speed. What is an angular speed? Angular speed is how fast is this CD or this DVD turn. So this is called the angular speed. Okay, so so we got two types of speed in this case. So the linear means it reads straight forward. The angular is where it reads when it rotates, when you go rotating. So so one of the formula for the angular speed in this case is omega over by theta divided by time. So the symbol here is omega. Theta in this case is the angle. So this angle forms by when you read it, and over time. And that is a relationship between linear and angular speed. This is actually important formulas. This is actually more important. Then I should take this away. So this is not important. So it's gonna give us by V equals to R times omega. V is the linear speed, R is the radius, and omega is the angular speed. So in order for us to figure out how fast you want to read this track, it based on two things: the radius of the track. So as you know that your CD turn around very fast, right? So that is the angular speed, you know, like how many revolutions per minute. And then also figure out what is the distance, because every time a track is a different distance, that is different radius of the disc. So and if you take that radius times how fast the disc spin, that is how your CD read your CD player read your sound music or movies or something else. Okay, so that one of the important for this kind of linear and angular speed, CD player is one of the one that we use a lot of this. Your car wheels, you know. So when you drive your car, you got two types of like speed. One is called miles per hour, like 40, 50, 60. That is called the linear speed. And then the other side, you will see like RPM, like revolution per minute. That is how fast your engine move. And your engine, it goes up and down, up and down. So it's kind of like a angular because it rotates in a circle way. So so that is how fast your engine move. This is called a piston inside the engine, how it moves. So so car is another one that also use this. So there is quite a few applications that use linear versus angular. Another one is a Ferris wheel. So if we look at a Ferris wheel, your Ferris wheel is going on circles, so it's an angular speed. But when you come to a certain, when you stop and when you go in and out, then you move, it's kind of like a linear speed once you stop. Okay, so so it depends on two types, and it's all based on the radius. So the bigger the radius is, it will take a longer time. Okay, to it's faster. Sorry, if your radius is bigger, you will move. Your linear speed will be faster. Okay, because if R increase, V in this case also will increase. Yep. So based on so this is very important formula. So let's take a look at some examples about this. And yes, it's very easy to figure out is if you see anything with revolution per minute, that is where we will use the linear speed in this case. Okay, so like question number 26 is asking us, you got a blade. This blade is rotating 5,200 RPM. So that means that this is like a saw blade. The 7.25, this is 7.25 inch, is the diameter. Okay, I do not know about this. I'm not a handyman. So I did ask people, I go to Menards and ask, what is this? Is that a diameter or radius? And they say it's always a diameter. So this is the form. The question says that you got a blade that is rotate based on a circular way, and the blade is 7.25. This is the blade, something like that, and it goes 5,200 RPM. First thing is they always will ask you to find what is the angular speed. Okay, our angular speed is usually measured in radian per minute. Okay, so this question is asking angular speed in radian per minute. So since we got 5,200 RPM, again, R stands for revolution. So if you want to change this to radian, we know that one revolution is how many radian? Anyone? One full circle, one revolution. How many degrees?
360.
And how about 360 degrees in radian? Is 2 pi, right? So what you do here is if you want to convert this into RPM to radian per minute, so we just take this multiply by 2 pi. Because every revolution is 2 pi, so if you this spin 5,200 times, so you multiply it by 2 pi. And again, usually we want to just leave this as pi, so you just take 5,200 times 2. So this angular speed in this case is 10,400 pi radian per minute. So this is how we do this question. Okay. This is how we do the angular speed. Question B is asking us to find the linear speed and when the saw teeth contact the wood. So when the saw is moving and when you make contact with the wood, that contact is actually linear. So in order for us to find the linear speed, we will use the formula of V equals to R times omega. Okay, but this question wants the V in feet per minute. Okay. Now, it's given us that this is diameter of this is 7.25 inches. So first we need to find the radius first. Okay, we need to find the radius first. So can someone tell me how you figure out radius if I give you diameters? Radius is, you take your diameter and what? Divided by 2, right? So can someone tell me what is your radius in this case?
3.625 feet.
Not feet, this is inches. Don't forget, this is in inches. Okay. And now we will, because the question wants us in feet, right? So we have to convert this into feet. So can someone tell me 1 feet is how many inches? One feet is
12.
12 inches. So what should we do with this to convert to inch to feet? Should we multiply by 12? Or should we divide by 12? Which one?
Divide.
Okay, so you have to divide by 12. So take out your calculator and divide this by 12. Because you had to convert this because of your question ones in feet. So what is 3.625 inches in feet? All those, right? You cannot round this. 0.30208. All this. So this is in feet. So now what we do is we got omega, which is this one, and we got radius in feet, and the omega is in per minute. So that's why it's feet per minute here. So what you do is you just apply this to your formula. So V in this case is radius, which is the one that you have, 0.30208, all those decimals that we have. And then you multiply that with what? The omega, which is 10,400 pi. So take out your calculator and take this value, the one that you have here, times with 10,400 pi. So in this case, your answer in this case will be 9,860, almost 70, 9,870 feet per minute. So this is your answer in this case. Make sure you guys know that the question, if the question wants it in seconds, then you have to divide this by 60 because 1 minute has 60 seconds. So but since this is already in minutes, so we do not need to worry about it. Questions for number 26. You don't have any questions? 27. I want you guys to do the same thing. This is very similar to number 26. It says that you got a DVD player, and the DVD player is having a diameter of 12 centimeters. So the diameter of this DVD is 12 centimeters. And the DVD reads between 200 to 500 RPM. Depending on what track is being read. So the first question is asking is find an interval, because this is an interval, right? So interval means where it starts and where it ends. So you start here, ends here. Find the angular velocity, angular speed, and then after that you need to find the linear speed. Now this question did not mention about what unit. So in this case, you do not need to do conversion. That means it's going to base on centimeters per minute. Okay, since the question did not ask us to convert. So go ahead, try to do this question now. The diameter is 12 centimeters of DVDs, and the DVD player reads between 200 to 500 RPM. So how do you find your angular speed? It's very similar to number A, part A here. If you know what we are doing here. So anyone here know how to do part A? 27A?
You do 200 times 2 pi,
And also what?
the 500 times 2 pi.
Yep. So in order for us to find the angular speed, you just multiply this. So 200 times 2 pi is 400 pi. So that means in the interval, we just start from 400 pi to 1000 pi. So this is how you write this in the interval notation. Means you start from 400. How 400 pi is 200 times 2. And then 500 times 2 is 1000. So this is what your answer looks like. So in your online homework, if they ask you for this, you just need to make a bracket on it and put this, comma that. Questions? You need to find the angular, the linear speed in this case. So the first thing you need to do is figure out what is your R. So anyone know what is your radius here? Radius?
6.
6. So what you do here is, this is 6 centimeter. So what you do is you multiply this by 6. So in this case, it's 6 times 400 pi and 6 times 1000 pi. So can someone tell me what is your linear speed in this case? Between what number?
7,539.822,369.
Wait. 2400 times 6 times pi, right? So this now, instead of that, we can also write this as just 2400 pi to make it nicer, and 6000 pi, because the pi is the one that makes it all icky. So this will be centimeter per minute. Okay, so your answer in this case is 2400. The lowest is 2400 pi, because 6 times 400 is 2400, and the highest, the linear, is 6000 pi, which is 6 times 1000, and the units is centimeter per minute in this case. So this is how we do question 27. Very similar to number 6. The only difference here is it has the beginning and it has the ending point, the interval we call it. Anyone okay with this one? Anyone have any questions? Right. We got one more left here, is the area of a sector. Okay. So what is a sector? A sector is an area of a circle. It's like a pizza, a slice of pizza. Okay. So this is called a sector. Okay. And the formula for the area of the sector is given us by this. A equals to 1/2 r squared theta, where r in this case is your radius and theta in this case is the angle. Okay, from for this, but this theta is going to be measured in radian, not degree. Okay, so this is the meaning of the formula of the area of the sector. So this is very important. So example in this case will be like question number 24. So if you read question number 24, it's asking us that you need to find the area of the sector. Given us that the radius is 12 millimeters and the center angle, which is theta in this case, is pi/4 radian. Now the good news about this is the theta is already in radian, so you do not need to convert it to radian. If it's a degree, you have to convert. So what you do now, class, is plug all this into this formula. I want you guys to go ahead and do it your own. Plug all this into this formula and see what you guys got. You have to use your calculator. Because it is an area, the unit will be square. Okay, so don't forget, we got millimeters. So the unit will be square in this case. Anyone got an answer here?
2.7270.
If you want it in terms of pi, you just do half times 144 because 12 squared is 144 divided by 4. So this is 18 pi. So if you want to just write this in terms of pi, this is 18 pi millimeters. But if you want it in terms of decimals, then you just take 18 times pi. You will get, is that what you get, Kelvin? 56.55, somewhere around there.
Yep.
So again, how do you know what your homework wants or my homework wants? If they're asking for round in 2 or 3 decimal places, then your answer will be 56.55 or 549 up to it. If the question did not mention about decimal places, like they want you, then your answer is 18 pi. Okay, so make sure you read the question carefully. If they say no, didn't ask for any decimal places, means it's in terms of pi. Otherwise, you have to use pi in your calculator to figure out the 2, 3 decimal places. Okay, questions? I want you guys to read number 28, and I want you guys to figure it your own how we do question 28. The question will provide you the radius, and the question will provide you the theta. Then you just need to apply the formula. Avery, what is the radius of this question?
7.5.
No. Now, this one you do not need to divide by 2 because when you talk about the water sprinkle, so this is where it springs and it will spring like that and then it comes back, right?
I see.
So your radius, this is your water sprinkle here. So your radius in this case is actually what?
15.
15 meters, yep. And your angles is what?
150.
150 degrees, but as you know that your theta cannot be what? Degrees. So I got students just plug this into this formula and they got wrong in the test. So you need to do what with this 150 degrees?
Times pi over 180.
Change to radian, yes. Anyone know what is this in terms of pi? 0 will cut off. This is 5 divided by 3, 5 pi over 6, right?
Yep.
So now what you do is plug this into this formula, 1/2 times radius 15 square times 5 pi over 6. Make sure you guys do this for me. Anyone got an answer here?
Got 294.52.
294.52 meters squared. 0.5 times 15 times 15 times 5 over 6. So if you want, you can write this as 93.75 pi, right? But if you multiply this with pi, you should get what Gamal told me. Yep, 294.52. You guys all right? Not difficult, right? The only thing is difficult is formulas. So if you do not know the formula, or you forget the formula, or your formula is wrong, then everything here is going to be wrong. So make sure you guys know the formulas. Otherwise you get it wrong. Questions for me before we move to 6.2? This is the end of 6.1. Okay, so 6.2 is talking about right triangles. So as you guys remember, right triangle means it is 90, it's an acute. Okay, so acute is what? Between what angles? Anyone know acute?
0, 90.
0 to 90s. So that's the reason why that our triangles is in between. For 6.2, when you do your homework, is your angle is always 0 to 90 or 0 to pi over 2. In order for us to figure out this 6 trigonometric function, we got the sine, we got the cosine, we got the tangent. This is pronounced as cosecant. Okay, and cosecant is actually the inverse, or is the reciprocal of sine. You guys know what's the meaning when I say reciprocal of sine? That means the number value will be switched. Okay, so if sine 30 degrees is 1/2, then cosecant 30 degrees is 1/2. If you flip it, it becomes 2. Okay, you just flip-flop the value. Okay. This SEC is called as secant. Secant in this case is the is the reciprocal of cosine value. So that means that if your cosine 60 degrees is 1/2, then secant 60 degrees is 2, 1/2. You flip it. This means cotangent. Cotangent is the reciprocal of the tangent value. Okay, so these are the few things that we have 6 of them. So trigonometry, we only got 6. So if you know sine, cosine, tangent, you should know cosecant, secant, and cotangent. You just need to reciprocal it, flip the values of it. Okay. So the short form for cosecant is CSC. The short form for secant is SEC, and the short form for cotangent is COT. How do you find the value? We will use this right triangle. So this right triangle, I'm going to draw it here. You need to know how to label this. So let's say that this is the angle, theta, like 30 degrees, 40 degrees, 60 degrees, you know. The one that across from the angle is called the opposite. The one that close next to this is called adjacent. And the one that go across is called hypotenuse. This is the one the longest one, you guys know that. And in order, usually in the test, I provide you 2 of this. You have to figure out the 3rd one. So in order for you to figure out the 3rd missing one, you have to use what? The Pythagorean theorem. You guys know the Pythagorean theorem, right? What's the Pythagorean theorem? Hello, Pythagorean theorem.
A squared plus B squared equals C squared.
And what is your A and B and C here? That's correct. A in this case will be your adjacent. B in this case is what? Your opposites. Your C in this case must have be what? Your hypotenuse. And yes, A and B can be interchangeable, means that your A can be opposite, then your B is adjacent, but C has to be your hypotenuse. So now here comes the important part. In order for you to find what is the sine theta is opposite over hypotenuse. So these 2 values, this value, you are by that value. Okay, so that's why we have a shortcut for it, and the shortcut in this case is called SOLVE. So means sine opposite hypotenuse. Okay. Cosine in this case is adjacent over hypotenuse, and we will call it as CA, because C is cosine, A is adjacent, H is hypotenuse. And the last one we have is tangent theta. So tangent theta in this case is opposite over adjacent. So whatever value you find in your opposite and adjacent, you divide them, and we call it as TOA. So it's tangent opposite adjacent. So this is called SOHCAHTOA, and we use this a lot in this chapter 6, 7, and 8. So chapter 6 and 7, 6 and 7 a lot. We use 6 and this is 6 and 7. Once you know sine is opposite over hypotenuse, then we know the cosecant, which is the reciprocal of sine. You flip it. So cosecant theta in this case will be hypotenuse over opposite. Secant theta, which is the reciprocal of cosine, you flip it, is hypotenuse over adjacent. And then tangent is cotangent, which is a reciprocal of tangent. You flip it, it's adjacent over opposite. You guys got what I mean here? Now, a lot of students during tests, they forget to give me this theta. Okay. If you forget to give me that theta, I will take points off, because there is no such thing as sine equals to a number over number. You forget the angle. This is an angle. So you need theta here. Don't forget theta in this case is, so I want to point out to you here, all this theta is your angle. Okay, 30 degrees, 40 degrees, 10 degrees, 50 degrees. All this that you divide is not angle. This is called the value. Okay, so a lot of students get these two confused in my class, and they thought so when you do sine has to be an angle next to it, and then this is equals to a number, a value in this case. Okay, so you guys need to practice a little bit more. All right, so I want you guys to do question number 12, number 1. You need to find the 6 trigonometric functions for this case. So this is theta, this is 12, and this is 5. So I want you guys to figure out what is your hypotenuse in this case.
$13.
Okay. 13 is correct. So this is what we call as triplets. So we have what we call as a Pythagorean triplets, where if you know 5 and 12, the other one, the hypotenuse will be 13. Don't forget, the biggest one is along the hypotenuse. There is also another famous one, is 3, 4, and anyone know? 3, 4, and 5. So that means that if both A and B is 3 and 4, your hypotenuse is 5, using your Pythagorean theorem. And if you multiply this with an integer, like with a number like 1, 2, 3, 4, 5. So if you multiply this by 2, so 6, 8, 10 is also another triplets. Or 9, 12, 15 is also another triplets. So these are this will help you, because you do not need to spend time finding this value using your Pythagorean theorem. So some of you just know 13 straight away without doing any work. Okay, otherwise you have to apply. If you don't have a triplets, that means this is 5 and this is 2. You cannot. There's no triplets, then you are forced to use the Pythagorean theorem. Okay. So using this, what is sine theta in this case? What is the value for sine theta?
5 divided by 13.
So it's opposite over hypotenuse, 5/13. Cosine theta in this case is 12/13. And tangent is tangent theta,
5/12.
5/12, which is opposite over adjacent. This is very important. It looks easy, but you need to know this. And then then you need to do the reciprocal of it. So sine, the reciprocal is cosecant theta. So what is cosecant theta in this case?
13/5.
So flip this, 13/5. Cosine will be secant, the reciprocal. What is secant theta is?
13/12.
Flip this value. And cotangent is the flip of tangent. So what is the reciprocal of this? 12/5. And this is how we do the first question. It looks easy, right? Well, wait till you do it your own. In the test, we will talk about that in your test. This is kind of coming in your third test. Okay. Question 2. Now, if I give you a picture, it's easy for you to do, but this question 2 does not give you the picture. So you have to draw it out. So sketch a right triangle for this angle. Find the 5 trigonometric functions in this case. So they're asking you for cosecant theta equals to 9. Now, make sure you make that value become fraction. So this is 9/1. So if you look at this cosecant theta is what over what? Hypotenuse, opposite, or adjacent? What over what?
Hypotenuse over opposite.
So cosecant theta is your hypotenuse over by your opposite. So that means that this is going to be 9 and this will going to be 1. So adjacent is the one you need to find. So I want you guys to go ahead, use the Pythagorean theorem because there's no shortcut for this. I want you guys to figure out what is your adjacent in this case. I want everyone here to do it. You should know the Pythagorean theorem. Apply, this is your C. Don't forget your hypotenuse is always your C. This one can be your A or B. Since this is A, I use B here because it's easier. So go ahead, find your adjacent. Everyone, do it now. What is adjacent here? That long? Andrew?
I don't know. I got the square root of 80. I don't know
That is
what
correct.
we reduce that to.
So this is square of 80. Now, do not use your calculator to find root of 80. You got a bunch of numbers, 8 point something. Yep, Nukini, correct. Do not do that, okay? In your test, I do not want to see that 8.94 in your calculator. How do you reduce this? How do you simplify this? Is you have to use the perfect square. So what perfect square? You know perfect square, right? 2 times 2, 4, 3 times 2, 9. So 4, 9, 16, 25, those numbers are perfect square numbers. What perfect square numbers can goes into 80?
8.
8 is not a perfect square.
4, 4, and 5.
4 and what?
16.
16. So we need the biggest one. So 16 times 5. Okay. So root 80 in this case is what? 4 root 5. So 16 is a perfect square of 4. So that's why you can put this one out. So you will use 4 root 5. You guys all right here? So this adjacent with 4 root 5, hypotenuse will be 9, opposite will be 1. So now you will apply this again. So what is your sine? I'm going to use this one again. So what is sine theta? What is cosine theta? What is tangent theta? And what is, we'll do this 3 first before we continue with the rest. So obviously the sine. Anyone? Using
1
this.
over 9. Is it 1 over 9?
So sine in this case will be 1 over 9, which is opposite over hypotenuse. What is your cosine in this case?
4 square root 5 over 9.
So it will be 4 root 5 over 9, which is adjacent over hypotenuse. Tangent,
1 over square root 4 over 5.
1 over 4 root 5. Now, this is something I want to point out to you guys is if you use this in your test to write this, you won't get full points because you have to rationalize it. You guys know what's the meaning when I say rationalize? You cannot have root in the denominator. So how do we rationalize this? Is we multiply this by root 5. So this is actually is root 5 because 1 times root 5 is root 5. This will become 4 times 5. So you still have the 4. Root 5 times root 5 gives us 5. So 4 times 5 is 20. So this is the tangent we are looking for. Tangent theta in this case is root 5 over 20. Now, how do we figure out the cosecant, secant, and cotangent? You take all this and you flip it. So 1 over 9 become 9 over 1. This one, secant theta, is a reciprocal of cosine theta. So you flip this. This is 9 over by 4 root 5. And again, we have to rationalize this. So again, you multiply this by root 5. And you have to multiply this by root 5. So what we get in this case is 9 root 5 over 20. Because you get 4 times 5 now here. Now, cotangent theta, do not flip this. The reason why I do not want you to flip this is because if you flip this, your square root is back in your denominator. Then you have to rationalize it. You have to do a lot of work. So what do I do is I just take the one before you rationalize it. I flip it. So this will become just 4 root 5. Okay. So what I want to point out to you guys is that if you see a root in the denominator, you have to rationalize. Rationalize means you cannot have square root in your denominator. And for the secant, cosecant, cotangent, make sure when you flip the value, make sure you flip the value that your denominator has a square root, because when you flip it, it goes upstairs. You do not need to rationalize it. Okay. So this is how we do this kind of questions. Questions you have for me? Anyone? So this is 6.2. So now we're gonna do a little bit on 6.3. Yes, we'll move a little bit fast here. Now, what is 6.3? 6.3 is where you will have trigonometric function of any angle. So that means it can go from any angles you want, 0 to 360 or 0 to 2 pi, and it can go more than one revolution. Okay. So in order for you to do this kind of SOHCAHTOA, what you need to do is you have to figure out what quadrant it belongs to. Okay, as you guys know, this is 1, 2, 3, 4, right? It's fixed. So if you guys want to figure out what triangle you draw, your triangle will look like a ribbon. So if you draw a ribbon like this, okay, and these are all theta here. Theta is, oh, this is theta, this is theta, this is theta, this is theta, this is theta. Okay, so that means that in quadrant 1, you will get the blue color one. So this is what we draw like this. This is in quadrant 1. Okay, this is quadrant 1. This is your theta. Quadrant 2, you will get the red one. So quadrant 2 triangle will look something like this, where this is the angle here. Quadrant 3, you will get this one. It looks like that. And your angle is here. And quadrant 4 is this fellow. You will look something like this, and your angle is here. You guys all right with these 4 quadrants triangles? They look different. Okay. Now, as you know that quadrant 1, the value for x and y are positive. Your hypotenuse is always positive values. Okay. Because you take a square root, you cannot have a negative square root. Quadrant 2 is special because when you look at your x value should be negative, but your y value should be positive, and this is positive. So be careful with quadrant number 2 because your like here is no longer 12, it's going to be negative 12. Quadrant 3 is even special because both the x and the y values are negative. Okay. And in quadrant 4, your x value is positive and we go down, so the y value is negative. So this is how you figure out your quadrants here, and this angle is your u, and then we will still apply using SOHCAHTOA here. Okay, and if you apply SOHCAHTOA, you will notice that in these 4 quadrants, all the trigonometric functions in this quadrant 1 will be positive. And in this case, if you look at here, the opposite over hypotenuse, opposite over hypotenuse is sine. So you find out that sine and cosecant value in this case will be positive. Here, when you look at this, when you divide these two, which is opposite and adjacent, tangent. So you find out that your tangent and your cotangent value will be positive. And then for the last one, when you look at adjacent and your hypotenuse, you find out that cosine theta will be positive or secant theta will be positive. And the rest of the trick is negative. So we can kind of summarize this to become A, S, T, C, where we always short form this to all students take calculus. All in this case means all 6 trigonometric functions are positive. S means sine, so sine and cosecant. So sine and cosecant will be positive. T for tangent and cotangent is positive. C is cosine and secant is positive. So, and the rest of those that I mentioned it will become negative. Okay. So this is very, very important. Okay. So now what happens with 6.3 homework here is it looks very similar to 6.2, but you just need to watch for your sign in this case. For example, you got a point. The point is negative 410. So where is negative 410 in here? Anyone know what quadrant is negative 410?
3.
No, 3,
Two, sorry.
2 here, right?
Yep.
So you go -4 here, and then you go 10 here, right? So when you draw me the triangle looks something like, oh, I should use weight, like this. Okay, so I just make this look bigger, the triangles. So the angle theta is here. This is the angle theta here. Can someone tell me what is this adjacent value? That is your x value. So this is going to be what? -4. And this is your y value is 10. So can someone tell me what is your hypotenuse here? You have to use your,
Square root of 24.
I'm sorry,
26. Square root of 26.
116,
16.
right? So 10 is 100 squared. 4 is 16, so 116, right? Can we break 116 down? Is 116 can be divided by 16? Nope. 116 divided by 4? Yes. So 116 can be divided by 4. So this is 4 times 29, which is the same as what? 2 square root of 29. So your hypotenuse in this case is 2 root 29. And this is your opposite. And this is your adjacent. So can someone tell me what is sine theta here?
Ten over two squared 29.
So it's 10 over by 2 root 9. And we have to do some reduction, simplify. So 2 and 10 can be reduced to become 5. And as you know that I don't like root 29 down there, so I have to rationalize it. So I just move the root 29 on top, and then this becomes 29. So sine theta in this case is 5 root 29 over 29. Anyone know how to do the cosine theta in this case?
-4 over square root 2 over 29.
So -4 over by 2 root 29. Again, we need to reduce this. This and this will cancel, become -2. So if you rationalize this, this is -2 root 29 over 29. How about tangent theta? Anyone?
10 over -4.
And this opposite over adjacent, reduce this to become what? -5 over 2. So this is how you find your sine, cosine, tangent. So now we need to do the reciprocal, which is cosecant theta. So what is cosecant theta in this case? You take the sine and you flip it. Don't flip this one, but flip this fellow.
Square root of 29 over 5.
Beside Kelvin, I need to ask you for secant theta. Ethan, what is secant theta in this case? Ethan? Ethan?
2 square root 29 over -4.
So reduce it, become, so take this and flip it. So it should be negative what? 29 over 2. Because you got 2 and 4, right? The 2 and 4 can be reduced to become 1/2.
Yeah.
And cotangent theta, Ethan, are you there? This should be easy. Ethan? Which
2
is,
over -2/5.
yeah, it's not there. So this is how we do this kind of question. So it's pretty straightforward type. Okay, it's very similar to number 6.2, but your triangles will be a little bit different because you're no longer on it's no longer from 0 to 90 degrees. It can be more than one revolution in this case. Okay, now I want to take attendance here, so please type in present. Now, as you guys, yep, go for it. So another type of questions I like to ask in 6.3 is figure out what quadrant is this belongs to. So as you know that all students take calculus. So all means all, sine, tangent, cotangent. So when I ask, if I give you sine theta is less than 0 and cosine theta is greater than 0, what quadrant is this belongs to? So in order for us to figure out what quadrant it belongs to, Ethan is there typing present. You have to figure out what makes sine theta less than 0 means negative. So can you tell me what quadrant sine theta is negative? Less than 0 means negative. What quadrant makes sine negative?
2.
2 is positive. So this is sine.
3 and 4.
3 and 4. So these are the 2 quadrants that make him negative. And what quadrant make cosine? What is this greater than 0 stands for? Negative or positive? Positive. So can someone tell me what quadrant makes cosine positive? There are 2 quadrants also.
Four.
And 1. 1, because 1 means every single one of this.
Yeah.
So can you tell me which of these quadrants overlap? That will be your answer.
4.
This is quadrant 4. So in order for have sine is negative and cosine is positive, your answer will be quadrant 4. So class, if you doesn't know this, say goodbye to the rest of your trick. This is important. Next, I'm going to give you guys figure out tangent negative is less than 0. Cosine negative, cosine theta is also less than 0. So what quadrant is this belongs to? Tangent theta is less than 0. Cosine theta is also less than 0. What quadrant is this?
2.
Okay, so that is quadrant 2. So Andrew, is it Andrew, right?
Yeah.
Can you tell me how you get quadrant 2 here? Which is correct.
Well, tangent and cosine, 3 and 4, they're positive in each of those. And then the first one is everything positive. So it has to be quadrant 2.
So quadrant 2 will make tangent negative and what? Cosine
Negative.
negative. Yep. So now I give you question number 2 here. You also have to find the trigonometric functions. But first thing first is you have to figure out what quadrant is this belongs to. This is cotangent, right? Cotangent in this case is -3. Cosine theta is greater than 0. So can someone tell me what quadrant makes cotangent theta negative, but cosine theta positive? And if you get this wrong, it's very bad. Nukin, Avery, Ethan, you can tell me what quadrant is fulfilling this too?
The 4.
That's Kelvin. So Kelvin, can you explain why it's quadrant 4?
Well, cosecant is positive in the fourth quadrant,
And cotangent is
positive in the third, but it has to be
negative. Yep, in the fourth quadrant, right? It's negative in 2 and 4. So this is the fourth quadrant. Do you guys remember the picture for the triangle for quadrant 4, what it looks like? Because the question wants to find the 6 trigonometric functions. So for the picture for quadrant 4 is this picture, the one I shaded in orange. So this is the picture we will draw for quadrant 4 triangles. This orange one. If you give me the wrong quadrant, your triangles looks different. And if you remember in quadrant 4, which one is negative and which one is positive?
opposite is negative.
So this is opposite is negative, both adjacent and hypotenuse is always positive. If you give me no matter what quadrant you pick, your hypotenuse is always positive. Can you apply this SOHCAHTOA here? So this is over 1. So what is opposite? What is cotangent? Cotangent is what over what?
The adjacent over the opposite.
So that means that your adjacent is 3, positive 3, and your opposite here is what? Negative 1. So don't forget the negative. Can someone figure out what is your hypotenuse here?
The 10.
That will be 10. Okay. Now, what we do here is you figure out what is sine theta, cosine theta, and tangent theta. You guys know how to do this one, right?
Yep.
So Avery, can you tell me what is sine theta in this case?
Would that be -1 over square root of 10?
Very good. Opposite over hypotenuse. Can you rationalize this, Avery?
Would it be -10
Negative.
over 1?
Nope, just move the root 10 up.
Oh, I see.
So it's negative root 10 over what? Over 10.
Just over 10.
Okay, so make sure when you see a root in the denominator, you just move it up, and then the bottom one, you just erase the root off.
I see. Thank you.
That is the quickest way to do it. Okay. It's always like that. Let's try someone else here. Henry, can you tell me what is cosine theta in this case? Henry? Something like that. 3 root 10. Yep, it's 3 square of that. There you go. Thank you so much. 3 square of 10 over 10. That's correct. And tangent theta. I'm still waiting for Ethan. Ethan, can you tell me what is tangent theta here? Should be easy. Ethan. Ethan, are you there? Gosh.
-1/3.
-1/3. Thank you so much, Kelvin. So Ni, can you tell me what is the reciprocal of sine cos? Ni? Ni? Ni, are you there? Andy, what is the reciprocal of sine cos? We have a name for it. What is it called?
Cosecant.
And what is the symbol we use here for that?
CSC theta.
Yep. And yes, Ni, that is correct. I'm not asking for the value. So that is -√10. A lot of students, they doesn't know what it's called. They put SEC. That would be wrong. Okay, because SEC stands for what? It stands for secant, and secant is this fellow. So can someone tell me what is secant theta in this case?
Or 10/3.
And you do not need to do cotangent because cotangent is already provided to us here. So cotangent theta in this case should be -3. You guys doing all right here? Questions with this? So it's very similar to what we did, right? Of 6-2, but you just your pictures looks a bit different. Okay. Now we're gonna figure out the exact value. That's the one. So every time when the question is asking for exact, what is the exact value of sine 30 degrees, sine 45 degrees, and so on, then you have to use this unit circle to figure out the exact value. So how do we figure out the exact value in this case? The only type of exact value we use here is either 30 degrees, 45 degrees, and 60 degrees. So if you use the unit, if you look at this unit circle, we are only doing the 30, 45, and 60 degrees. So we don't use 15 degrees. We don't use 75 degrees. We don't use, that means if you see anything that is over 12 in your radian, we don't do that. Okay, we don't do those. So we only concentrate on 30, 45, 60. And 30 degrees is always over 6. So pi over 6. So if you look at, I'm going to use a different color one. So you will see pi over 6 is for 30 degrees. And then if you look at the next over 6 is 5 pi over 6 is 150. So, and then if you look for another one, 7 pi over 6 is 210. And the last one is 11 pi over 6 at 330. The one that I put the checkpoint in blue, they are what we call as reference angle to 30 degrees. So that means that if I ask pi over 6, it's going to be 5 pi over 6, 7 pi over 6, and 11 pi over 6. Or the 30 is 30, 150, 210, 330 degrees. That is called a reference angle for this case, for 30 degrees. If I ask for the 45 degrees, then the reference angle will be over 4. So it will be 45 degrees of pi over 4, 135 degrees pi, 3 pi over 4, or 225 is 5 pi over 4, and 5 pi, 7 pi over 4, 315. So the yellow one that you see, I put the checkpoint, that is the reference angle for 45 degrees. And the last one that we have in this case will be 60 degrees. 60 degrees is, if you look at your radian, it's going to be over 3. So 60 degrees or pi over 3, or 120 degrees 2 pi over 3, or 240 is 4 pi over 3, 5 pi over 3, 300 degrees. So these are all reference to 60 degrees. And each one of these is in different quadrants. So this is quadrant 1 from 0 to pi over 2. And then pi over 2 to pi is quadrant 2. And then quadrant 3, and then quadrant 4. And then if you want to go more circles, then you just keep on going 1, 2, 3, 4, 1, 2, 3, 4. And don't forget, this is for positive angles. What happens when you got negative angles? You have to go clockwise. So you're going to be quadrant. So instead of quadrant 1, 2, 3, 4, you're going to be 4, 3, 2, 1. So if you go to if your angles is negative, okay. And then we got the special one. The special one only exists on the axis. So on the x-axis or on the y-axis, which will be the 90, the 0, the 90, the 180, and the 270, and the 360. And again, the radian is either pi over 2, 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi. This is back to 2 pi. So this is kind of like a what we call as a reference angle for 30, 45, and 60. And we don't do any other angles beside these 3. Okay, and then this is all reference again. So what happened is that how do we figure out 30, 45, 60 in this case is, this is very important. So please know this. Sine theta is the y value of the coordinates. Please write this. Cosine theta is the x value, and the tangent theta is the sine over cosine, so it'll be y over x value. Okay, so what is theta? Don't forget, theta in this case is your angle. So your angle in this case will be like 30 degrees or pi over 6 or so on. So these are your angles, your theta. And the value, I will show you how you figure out value here. So let's start with 45 degrees. Okay, we're going to start with 45 degrees. So in order for us to get 45 degrees, we will have to use what we call as an isosceles right triangle. And when I say isosceles right triangle, means that these two are exactly 45 degrees. That means they are having the same same length. And I'm going to put this as 1 and 1 because they are the same equal length. So the hypotenuse in this case will be square root of 2. And the reason why I use 1 and 1 is because that's the smallest number we can have. You can use 2, 2, and you have to use the same because they are the same value, or the isosceles means the same length. So this one is 1 square plus 1 square, that's why it's 2. So can someone tell me what is sine 45 degrees based on these triangles? Anyone?
Is it 1 over square root 2?
Which is, if you rationalize this, is
Square root of 2 over 2.
How about cosine 45 degrees? That's correct. Same thing, right? 1 over root 2, which is the same thing as root 2 over 2. And what is tangent 45 degrees? This is 1. Okay. So what happens to your unit circle here is, don't forget, sine is your y value, cosine is your x value. So this 45 degrees, okay, to use the yellow, the value for this will be square root of 2 over 2. square root of 2 over 2. That means that for the sine 45 degrees, it is root 2 over 2, cosine root 2 over 2. And I'm going to put one more. If you take y over x, this is exactly 1. And this is for tangent. Okay. So this is for your x value, this is for your y value. And so this is for 45 degrees. So the one that corresponds to 45 degrees or pi over 4 is 135. Now, since this is in quadrant 2, can someone tell me what value is negative in quadrant 2? The x
Y.
or the y value?
X.
The x. So it's going to be exactly the same as this, but it's going to be a negative on the x value in this case. And because that is a negative, so you divide by positive. So when for tangent, you get negative. Because if you divide these two, you get negative. And if you look at the 225, which is the same as 135, this is in quadrant 3. So what value are negative in quadrant 3? Both the x and the y values are negative in quadrant 3. But when you divide this, you become positive. And what happens in quadrant 4?
The y
What?
is negative.
The y is going to be negative. So that means, again, when you divide, you get a negative 1. So what is going on here, class, with this is if you look at this value here, if I ask for what is cosine 315 degrees, cosine 315 degrees is what? Square root of 2 over 2, because cosine is the x value. Can someone tell me what is the sine of 135?
Negative square root 2 over 2.
You get sine is the y value, not the x value. Is what? Still positive with 2 over 2. You guys with me here? What is the tangent of 7 pi over 4? Tangent of this angle. Then you look at the y over x. What's tangent in this case? Negative 1. So tangent 7 pi over 4 is negative 1. So this is how we figure out the 45 degrees. Okay. Yep, this is tough. Now we're going to do the 30 and 60. So in order for us to do 30 and 60, I will use the equilateral triangles, means everything the same. And all the angles will be the same, 60, 60, 60. Because as you know that, right, the total has to be 180. So equal means they all has to be the same. So I'm going to put this all as 2 instead of 1 unit. This is 2 unit. And I'm going to take a knife and cut this right in the middle. And I'm going to concentrate on just one of this triangle. This will be 2. If I cut this right in half, this is a 1 because it's 1 each. This will be 60 degrees. And this will be 30 degrees. I'm going to use the other color here, purple. Can someone tell me what is this is? So you have to use your Pythagorean theorem. This is your C, this is your A, we figure out B. So C squared is 4, A squared is 1, plus B squared is B squared, because we use a B. So anyone know what is this value will be?
Root of 3.
With 3. So what we're going to do here, class, is we're going to do 30 degrees here. So 30 degrees, that means this is your opposite, 1. Adjacent is root 3. So what is sine 30 degrees in this case? One over opposite, 30 is right here, opposite over by hypotenuse. What is cosine 30 degrees? Adjacent over by hypotenuse, root 3 over 2. And what is tangent 30 degrees? Is opposite over by adjacent. So in this case, it's just what? Root 3. You guys okay here? So now we will apply again. Don't forget, sine is your y, cosine is your x, tangent is y over x, sine over cosine. So we're going to apply this into your unit circle. So, but this time we're going to apply for 30. Okay, 30 is blue, sorry, wrong color. So if you look at the 30 degrees one, the x value is root 3 over 2. The y value is 1/2. So in this case, if you look at this blue one, it's going to be square root of 3 over 2 and 1/2. And for the y over x, this is square root of 3. So this is for what? 30 degrees. So don't forget, this x value is for the cosine 30 degrees or cosine pi over 6. The y value is for sine 30 degrees or sine pi over 6. The y over x is for tangent. Now you flip it to quadrant 2. So you will get back exactly the same thing. But since in quadrant 2, your x value is negative, right? So that makes the y over x also negative. You guys all got this one? And then same thing with this one. In quadrant 3, both of the x and the y are negative, but when you divide, it's positive. And then in quadrant 4, you will find out that only the y value is negative, because quadrant 4 y, and then y over x is negative. So if I want you to figure out what is tangent 11 pi over 6, what is tangent 11 pi over 6? Is negative square root of 3. Okay, and what is sine of 210? Is sine an x value or the y value? Sine
Y.
is your y. So what is the y value for this 210?
Negative square root 2 over 2.
No. 210 is here, not 225.
Oh, negative 1 over 2.
Negative 1/2. Okay, so this is how we figure out the 30 degrees for the blue one. And lastly, we're gonna do the 60 degrees one. So 60 degrees, you're gonna use the green one. Don't forget, if you look at 60, your opposite is different from the 30 degrees. Okay, so what is sine 60 degrees in this case? Is opposite over by hypotenuse, which is root 3 over 2. Cosine 60 degrees is 1/2, which is adjacent over opposite hypotenuse. And tangent 60 degrees is what? 1 is, oh, this is wrong. Tangent, oh, this is wrong for tangent. Sorry for that. Tangent 30 degrees is not root 3. It's gonna be, tangent 30 is 1 over root 3. So the tangent 30 is 1 over root 3, which is root 3 over 3. This is wrong. Okay, so I'm going to change this back. So this is not square root of 3. This is square root of 3 over 3. Yeah, this is wrong for tangent. So it's not square root of 3. That is the other one. Yeah, this is root 3 over 3. So tangent is wrong. So make sure you change it back to root 3. This tangent is square root of 3 over 3. But for the 60 degrees is opposite over adjacent. This is square root of 3. Yep. So I just got those two mixed up. Don't do that in your test. And again, this is for your y value, this is for your x value, and this is for the y over x value. So now what we do here is, if you look at the unit circle, the green one, perfect, it's matching with the green one here. You find out that when you do your x is half, your y is √3/2. You notice something going on with this one is it's kind of switched around with the 30 degrees. So you will get 1/2 here, and then you get the square of 3/2 here. And then as usual, the y over x in this case is square root of 3. So what do you notice about 30 and 60 is your coordinates is switched around. Yes. Okay. And the 60 is correspond to 120. So you will still have the 1/2 and the square of 3/2, but then your x value will be negative. And when you divide, it'll be negative. The one that corresponds in quadrant 3 is 240 degrees. This case, your both x and y will be negative. But y over x is positive because you divide both negative here. And the last one, 300, which is correspond to 60 degrees. You also get the same coordinates, but this time your y value is negative. So your y over x will be negative. So these are all the coordinates for your 30, 45, 60, and it's all based on this triangles. This is very important that you do it. And finally is the special case. Remember, I told you that's the one that on the coordinates, on the axis, xy and xy axis. So when you have an x-axis, usually the point that we use here is right here. That means that your units is 1. So if you look at the coordinates of this point, it is going to be 1, 0. 1, 0 means that your x value, because if you think about your coordinates, this is 1. So your coordinates for this is 1, 0. As you guys know that when you divide y over x, you will get 0. Because 0 divided by 1 is 0. But for the 90 degrees, it's going to be 0, 1, because that is your x is 0, but your y is 1. So when you do y over x, this is undefined. The reason why it's undefined in this case is because your x is 0. Okay, so anything divided by 0 is undefined. For 180 degrees, we will be using -10 because it is on the negative side. So when you divide y over x, you will still get 0 because 0 divided by negative is 0. And then for 270, we will use 0, -1 because it's in the y-axis. So when you divide y over x here, you will still get undefined because your x is 0 in this case. So these are all the coordinates with all color coded here. Means that the blue is all correspond to 30 degrees, pi over 6. The yellow one is correspond to 45 or pi over 4, and the green one is 60, correspond to 60 degrees. And the black one is correspond to the x and y axis. This is super important. Plus, the sine theta always the y value. Theta is your angles. Cosine theta is x value, and tangent theta is y over x. This is super, 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 super important. And yes, in the test, I won't give you this. I will give you the one that is blank. That means without filling in. So you do need to fill in these coordinates on your own, and you can use that in your test number 3. Okay. Yeah, this is a lot to soak in here. This is getting a little bit tough. Trig function is a bit more difficult than what it is. So we're gonna stop here. I will give you some videos to watch on Monday. The videos will talk about how we use calculator to calculate this. And then I will also teach you how to figure out how to use the unit circle here. Okay, how do you use this unit circle to figure out what is sine, cosine? And you notice that I just do sine, cosine, tangent. So if you want to do the cosecant, so cosecant theta in this case, you just take 1 over y because it is just the reciprocal of the sine. Secant theta in this case will be 1 over x. Again, you flip your x. And cotangent theta in this case will be x over y. Okay, so once you know these coordinates, you just reciprocal it. That will be your cosecant, secant, and cotangent. So this is important. Yes, I will post this together with all the notes for today's with the link, Zoom link. So I do recommend you guys to really practice this or watch this again, especially the last one here. So I'm going to stop sharing here and start recording.